say one branch in the I'll say New Delhi, or else I'll give like this: branch 1, branch 2, and branch 3 are different locations. Okay, so let us say this branch is meant for operations, loan, and this branch is meant for the mortgage. So I can say retail banking. Okay, all for retail. Maybe it covers the loans also, and this is for maintaining the what do you call, so inventory. So there are 3 different branches and 3 different operations are there. Okay, let us assume by this time you have an overall 20 million customers, for example. Let us assume throughout the world you have 20 million customers. Okay, or else let me take like, so 20 lakhs customers practically. Okay, so you have 20 lakhs customers. There is a requirement actually. What is the requirement? You want to find the customers who are holding the account from all these 3 branches. Okay, so my requirement is, my question here is, okay, find the customers who are part of all 3 branches. How do you answer this? Okay, how do you answer this question? So you will be answering when you collect the data from 3 branches, and when you put it in one centralized place on the data. So first you need to collect the data from all these places and put it in one centralized place. Okay, so after that you will look into that to put the data in this place: branch 1, branch 2, and branch 3. So when you aggregate the data over here, from this data you will be able to find, so what and all the customers. So this storage is called as a, and also you need to get a data from 2022 till date. So this is a today's question. Same question may arise after 10 years. After that you will be getting you need to get the data from 2010 to 2031, right? So this is a storage. This kind of storage is called as a warehouse. Okay, what is the storage? The storage is for maintaining the history data, and when you see, you are collecting the data from 3 different branches, correct? 3 different places. Say, and also let's take a format of a data. Say this branch complete loan data is maintained in a file system. Okay, for example, this is a SQL Server DB, means database system. Let us assume this inventory they are maintained in a distributed file system or else cloud-based system, say Salesforce, cloud-based system. Okay, see here the systems are different, correct? So one kind of system is a file-based system, another kind of system is a SQL Server, another kind of system is a Salesforce. So you need to collect the data from 3 different places, or from 3 different places in the sense 3 different locations of 3 different data formats, right? So you need to integrate this data and put it into a place. So this should be integrated. And subject oriented. Usually subject oriented means subject is nothing but a type of a business. Here you see there is a one more question. So okay, find all the customers who are holding the who closed the loan. Find the customer who are availing the loans, for example. How do you get this answer? you will be getting this answer when you go to the branch one. So subject oriented answer. So it should give a, it should be helpful with respect to the subject also. Any storage that supports these three operations is called as a data warehouse. Usually we call it as a enterprise data warehouse. It is giving answers at enterprise data warehouse, enterprise level. Okay, so this is the definition of a warehouse given by the Kimball, one of the scientists. Okay, he's saying that data warehouse is a, again, what is this? What kind of storage is this? It's a DB only. It is a one of the DB. It could be a Oracle DB, or it could be a SQL Server DB, any DB. Okay, any storage that supports history. See, you should be able to get the answers. Customers who are availing the loan from 2015 to 2020 or else 2021. So a warehouse that supports a history of the data, and it is integrated, and it should be a subject oriented. Okay, when any storage supports this kind of operations, we call it as a enterprise warehouse. So logically it is a, physically it is a database only. Okay, logically it supports all these operations. Okay, this is called as a warehouse. So it is a warehouse for ABC Bank. Okay, we need to build this warehouse using our technologies. Okay, what are the technologies that will build this warehouse? Means answer is ETL technologies. Usually that is called as a ETL operation. Okay, or you can call it as a ETL tools. ETL operations will do by using the ETL tools. Okay, so these are the tools, okay, which will bring the data from various places into the warehouse. Okay, what are the various ETL tools? So like you have multiple ETL tools in the market. So there are many vendors providing the supporting the ETL operations of your enterprise data warehouse. What are they? So some things are Informatica is one of the ETL tool, and SSIS from Microsoft. Okay, and Data Stage from IBM. Okay, and also Talent from Talent. Okay, so these are the few tools in the market. These tools are bringing the data and put into the warehouse. Okay, so after that, what's your exact requirement and why are you loading the data? You need to analyze the data. You need answer for few questions. For this is a question. So to do this question, for these tools will bring the data into the warehouse, and you will analyze the data, and finally you will get answers to the question for your data analytical purpose, right? So why are you finding the customers? Because you wanted to analyze the data of those customers. What is the loan of the, or what is the interest rate in this period? Okay, so that will help you to take a business decision. You are building this warehouse to answer your queries. So by using that answers, you will improve your business. So overall, the warehouse is built for the data analytical purpose. So that's why this is also called as a analytical system. Usually one of the database used for data analysis. Used for data analysis that helps to take business decisions. Right. That's why you are building this. Okay, you want to collect the data and put it in a one place and analyze the data and finally take a decision. So by answering your questions, that answer with that decision will help you to help your business. So how the questions will be answered? Okay, find the customers who are availing the 25 from 2015 to 2021. Okay, I said 2000 customers, but there should be a proper report, right? So you will be getting all your questions answered in the form of reports. So who will generate the reports? The reporting tools. What are the reporting tools? Some other tools are Tableau is a reporting tool, and Cognos is a reporting tool from IBM. SSRS is a reporting tool from Microsoft, and there are some other tools, ClickView, ClickSense, These are from Click Company. Okay, there are a lot of other tools are there. Overall, you can call this is a data warehousing landscape. Okay, see, you have a data here, correct? And there are the tools here. This is your warehouse. And finally, these are the reporting tools. So this is called as a warehousing landscape. And I believe you are clear with the what is data warehouse, right? And why are we building the warehouse? Who will pump the data in the warehouse? ETL tools, extract, transform, load. These tools extract the data and transform the data as per the need and load it into the warehouse. And reporting tools, they will be actually take a data from data warehouse and generate the reports. Any questions? If someone is not from the data warehousing, so this is a basic information for you. Any questions here? Fine. If I have no other questions, what is the relationship between this entire picture to the Snowflake, right? So next question is, where do we build the warehouse? Okay, the answer is you can build this warehouse using database. Okay, using any database. Where do we build? You can put it in a on-premise or on cloud. You can build this warehouse in the two places. Okay, on-premise means you will buy your separate hardware for this, and you will have some database systems. You will have your own server and client for your network, right? And you use your hardware software configurations, and basically you use a hardware setup. So to build your warehouse, say my warehouse is I have my hard disk of 500 GB, so 300 GB is meant for my warehouse, right? Okay, so that is called as a on-premise. So same warehouse you can build on the cloud also. So same tools. These tools are used for bringing the data and put it into on-premise servers, or you can put it into the on-cloud databases also. What are the various clouds? You have three kinds of clouds. AWS is AWS cloud, and Microsoft Azure, and Google Cloud. Right. So every day we are working with cloud nowadays, right? Everything is cloud. Okay, you are actually uploading a file and you are saving your pics in the cloud, right? So and you are saving your database things in the cloud. You do so lot of operations in the cloud. So these are the three vendors. Okay, so you can build your database. You can have a Oracle database built on the AWS. You can have a SQL Server built on the cloud. Okay, in Microsoft Azure, whatever it is. So you can build your DB either in on cloud or on premise, right? Okay, that is a one place. And there is a another at the same time, these cloud systems are also very intelligent, and they have actually adapted the complete data warehousing technologies, complete this terminology. Okay, so these cloud systems started adapting these three features of a database, and they have introduced their own warehouses. So that is Redshift. Redshift is a warehouse means when I say warehouse, that supports all these operations. Okay, so and Azure, Microsoft Azure is a Redshift is one of the database. So Microsoft warehouse, this is also supporting one warehouse, and Google warehouse is also there. Okay, so can I say Snowflake demo? See, Microsoft Azure data warehouse, Redshift, Microsoft Azure Data Warehouse, Google BigQuery. So these are the, so what is the Google warehouse name? BigQuery. These are the warehouses proprietary to this cloud. Redshift is a AWS proprietary. Okay, so this, using this Redshift, you can do the integration of a data. You can have a history of the data. You can use this Redshift and connect with Tableau to generate a reporting tool. All right. Also, you can use Informatica with Redshift, and you use Informatica to load the data into Redshift. Okay, these all are cloud-based warehouses, right? So, and but the disadvantage is, assume that as of now, say, let us take this business. Let us assume this ABC Bank, okay, loan business they have done in a AWS. Also, for example, this retail business they are doing in the Microsoft Azure. Say inventory business they are doing in the Google BigQuery. See, a bank should be holding the license of 3 clouds. And what is the benefit out of it? It's maybe there is a benefit, definitely. Okay, and also they need to have a technicians that should be aware about all these clouds, and all these clouds has their own way of security policies. Okay, their own way of patches. Okay, when you have business like this, definitely, so you will be having a lot of difficulties in maintaining multiple clouds. Okay, your warehouse, assume that where your warehouse is built. For example, if entire warehouse is built on the AWS, a loans data is in AWS, warehouse is also in AWS, but retails data in the Microsoft Azure and your warehouse in AWS. What do you do? So you need to put a separate effort to do the cross cloud data movement, right? So that is the one more challenge you need to face. So by considering all these difficulties, a new technology came into the market around 5 years back, that is a Snowflake. What is this? It is also a cloud warehouse. Snowflake is a cloud warehousing technology. You can run your Snowflake, or you can use Snowflake in any one of the cloud, irrespective of the cloud. So you can build a warehouse. So say take a ABC case. So they can buy a Snowflake license and they can build a warehouse for all these operations. And at the same time, this Snowflake backend storage is a cloud only. It could be either AWS or Microsoft Azure or Google Cloud, whatever it is. So you can put in any one of the cloud. You can build a warehouse irrespective of your cloud. Tomorrow, one more cloud called as X come into the market. Yes, Snowflake is ready to support. So overall, Snowflake is a cloud warehouse. Okay, so you can build a warehouse in any of the cloud. So advantages are single point of storage, right? And you can have a single point of service provider, right? And if say you wanted to move from one cloud to another cloud, say your company is not happy with the charges of AWS, then simply you can move this to the Microsoft Azure. So that is a lot of advantage. One of the invention actually Snowflake came, and it is not taking the help of any existing technologies, any existing cloud-based technologies. Okay, so what I would like to say is, this is all about where are we building our warehouse. So I'm saying you can build an on-premise or on cloud. Okay, so your warehouse is Oracle, for example, you can build in on-premise or on cloud. Along with this, these are the 3 cloud providers in the market as of today. So these 3 cloud providers has proprietary warehouses. Okay, have proprietary warehouses. So Redshift is for AWS, and we have one more brand new warehouse in technology, that is Snowflake. So you can build the warehouse in any of the cloud. Okay, so irrespective of a cloud, you can build it. So this is again a cloud-based warehouse. So it's not an on-premise warehouse. Any questions so far from this diagram? If you are clear with this, then I'll go and start the Snowflake introduction. Thanks. Yeah, this document will help you understanding the Snowflake. Okay. You know, Snowflake is a cloud-based data warehouse, and it is a best example for software as a service. You know, right? So software as a service, so many are there. You are using a WhatsApp, no? That is a software, best example for software as a service. You can have your app in your mobile, and you can have a web-based WhatsApp, right? So this is also like this. When you wanted to work, when you are traveling in a train and you wanted to work, simply you can open the application from your mobile and you work. That is how the Snowflake is working nowadays. See, let us assume the data. How many records are there? 20 lakhs customer. Assume the 20 lakhs customer is close to 1 TB data. Assume so far they have generated a say find 50 terabyte data from 2010 to till today. So 20 lakhs customer generated 50 terabyte data. So you can have this 55 terabyte data opened in the mobile. Okay, so that is the best example for software as a service. Okay, so and also Snowflake enables its data storage, processing, and analytical solutions. I told you what is analytic. It's very faster and also very easy to use. How easy, you know? I'll show you. Your tool will be looking like this. Okay, this is the tool where you work. So no menu bar, no status bar, no toolbar. Only you have 1, 2, 3, 4, 5 menus. That's it. Five images. You will be working in this place. That's it. And also you write a SQL over here. I cannot say simple or complex. This is the very easy place to work. Okay. So it enables data storage, processing, and very fast and easy to use and more flexible. Okay, you see how flexible it is when we are working in the hands-on session. It's very flexible means, say, there is a data storage of, as per this diagram, so how many are there? 50 terabyte. This is the 50 terabyte today, right? So tomorrow it could be 100 terabyte. So your storage will keep increased. At the same time, your Snowflake will also flexible as per the data storage. Correct. So you will have that kind of the features already invented actually. Snowflake is not depending on any existing technology. It's a new invention. Okay. So how this is possible means, so Snowflake guys has come up with a special architecture. Okay, that architecture is especially taking responsibility of faster data processing. So easy maintenance, easy to use. Okay, so and also you will be paying for your usage only. So because of the architecture, so many advantages are there. So it is easily scalable and computation is very fast and your payment would be very less. I have seen a project which was a warehouse built on the Redshift to the warehouse built on Snowflake with almost 5 terabyte data. So company is seeing 40% of the saving cost. Okay, so it's you. What is the funda here? You are paying for what you use only. Just like uh, you are actually consuming the fuel for what you are driving. Same concept. Okay, so here you are paying for what you use. So because of this architecture only, Snowflake is very popular. So this architecture is built on top of JavaScript. Okay, so that architecture is a core of the Snowflake. Okay, yeah, this is how the architecture will be looking like this. So Snowflake architecture is a services based architecture, right? So when you see the architecture, you won't see big circles, right, and big links, right, and big boxes. You will see the architecture, right? So that it is not a so complicated architecture. Okay, the architecture is a very simple architecture. So it has only 3 layers: storage layer and warehouse layer and services layer. Storage layer is, as I told you, Snowflake is a warehousing technology. Okay, so where the data storage is available, so it supports any cloud. So your storage would be any of the cloud. Your data will be stored in the any of a cloud system. Either it's up to you, depend upon your company need. Either it is a AWS storage, or AWS cloud, or Azure cloud, or Google cloud, wherever it is. From the single storage, okay, so there is a one more layer called as a compute layer. So this compute layer is for operations. So virtual warehouse, you call it as a virtual warehouses are there. The symbol is a virtual warehouse. Virtual warehouse is a compute engine. So, and these virtual warehouses are organized in the form of clusters. So this is one cluster used for development. You know, clusters means collection of virtual warehouses. This is a cluster for development or for testing purpose. Say there is a banking system. This cluster is for finance. This cluster is for marketing. This cluster is for some ETL operations. So see the funda here. Centralized data will be accessed by the multiple clusters, and all these clusters will run on a common data using a virtual warehouse. Okay, to make it simple, virtual warehouse is a computing capability. So don't think that it is a storage, it's a computing capability. So that is a second layer, storage layer and compute layer. Finally, the storage and compute layer are organized by the services. You have only 1, 2, 3, 4, 5 set of services. First service is for optimization. Optimization means query performance improvement. Okay, so using this optimization service, he is actually seeing always performance of the queries, and he will reduce. Okay, and also he will optimize the storage in this cloud layer. So means doing compressing the data. In Snowflake, usually the storage is a compressed data. Okay, say you wanted to store how many records here? 50 terabyte data in the Snowflake. So it won't be 50 terabytes when it is going to Snowflake. It would be compressed. That would be around 25 or 30 terabyte data, right? So who are doing that service? The optimization service. Management means it is taking the responsibility of computation, is how computation is there, printing the statistics. Okay, so managing other services. Okay, this service is managing other services also, and also this management service is also responsible for sharing the data across the multi clusters. So, okay, so this actually it supports a multi-cluster. Snowflake supports. Okay, next is the transactions. Means so many people are coming into the Snowflake and reading the data. Say for example, here the Tableau, assume that this is a Snowflake warehouse. Tableau will come and generate a report, right? So and say this Snowflake is uh, being actually loaded by the Informatica tool. So again, there are some transactions will be performing, right? When the Snowflake wanted to communicate with outside environment, for the transactions, will be taking care of the transactions. So outside environment security, are we are logging into the Snowflake, right? Just now I logged in with my username and password. So the security is another option that will be authenticating by, I mean, that is taking care of a lot of security options. So securing the, for example, marketing data is looking for a specific set of data from the storage. So security will take care. And metadata means, you know, metadata, right? So data about storage, data about services. Say for example, how many services are there, what is the service name, I mean virtual warehouse name. Okay, so what is the storage available, so what is the metadata of the storage tables. So there are some tables that will be maintained in the metadata service. So this architecture is supporting the storage, compute layer and services. Very simple architecture. Okay, I'll try to help you how we differentiate this architecture with the traditional architecture. Okay, let me take an example. Say there is a product table, for example, in your banking environment, a product table. So I am using Oracle as my database and warehouse. Select star from the product. You know, select star is a command for product. Let us assume this is a 500 TB file. Select star from product. So I don't know, this is taking approximately 10 minutes. Can anyone guess the reason why it is taking 10 minutes? Any guess from anybody? What is the reason behind it? You are firing a query and find a TB. It is running for 10 minutes. Anybody wanted to interact with me? No problem. Yeah. So why 10 minutes? You know, here. Yes, Suresh. No.
Yeah.
So
I think the database processing, right? Means it will be indexing and
that could be the one reason. You are expecting
right.
indexing or partitioning, right? Okay. Nice answer. And any guess from others? Yeah. The reason behind is your processing engine of Oracle is trying to pick up 500 TB data. Correct. So your processing engine is looking for huge data. That's why your processing engine is getting slow. Right. It is trying to fetch the huge data. So the storage is a problem here. And at the same time, storage and processing engine are both are coupled here. Right. So when storage is keep on increasing, your processing engine is also traveling with the storage. Right. The storage and processing engine both are coupled in traditional databases. In traditional databases, right? I'm saying correct. Okay. Coming to the Snowflake, that is actually segregated. Okay, so in the Snowflake case, your storage and processing is completely separated. Okay, it's as simple as you want to drive your car for 100 kilometers, drive. At the same time, you wanted to add as many people as in your back seat, you add. Simple. So storage is different and processing is different. You wanted to increase the cloud storage, you increase it. And you wanted to increase the processing speed, you increase it. It's up to you. So that is the basic idea of the Snowflake invention. Okay, so that's why here you can see this storage is accessed by multiple computing environments, irrespective of the environments. Okay, at the same time, can you see this cluster? Again, it is a multi-cluster. Okay, this is a cluster, this is a cluster. And within a cluster, you can have as many processing engines as you have. So this is a where processing engines means virtual warehouse. As many virtual warehouses you will have, 3 virtual warehouses. All are running again separately on the on the data sets. Right. That is the core idea of this one. Okay. So that when you have like this, you will have a centralized management. Okay. So you can have one management service that can manage processing separately, that can manage the storage separately. Okay. So and also metadata is separate from the compute. That is the second assumption. So what is metadata means? How can I say? There is a table, the same product table. One guy say today is November. What is the date today? Today November 27th, right? One guy updated the table, updated the product. Okay. So say on December 10th, one of your client wanted to see the data before update. Okay, so assume that this product number 1 and the name is A. On November 26th, so A has been updated to B. So on December 10th, he wanted to see what is the value before B. Then what do you need to do? You have to go and contact your administrator and put a metadata at that particular time, or you need to get a metadata of operation happened on the November 27th. But that is not a case. You in the Snowflake, you can go back to your original data or old data, and you can see the old data. That is what actually metadata is separate from storage and compute. So there is no relation between metadata to the storage and compute. So that's why Snowflake is so popular. Completely divided and managed. It's okay. That is the core difference. I believe you are understanding why this is taking 10 minutes and why the same query will be running in a 1 minute in Snowflake. We can see that actually in the class. Any questions in the architecture? If you are clear with architecture, I believe 2% of your course will be done. Okay. Any questions from this place, guys? Right. Okay. So these are the some of the other benefits of the Snowflake. Okay. This is architecture, right? So let's try to discuss. Let us discuss all this stuff. It's a complete SQL database. Okay. So, yeah, this is SQL database. Again, you no need to have a separate language to be learned to work with the Snowflake. Okay. So to build a warehouse, you will write all your SQL statements. And once you are familiar with the basic SQL, you can build this. SQL knowledge is 20% of SQL knowledge is sufficient. Okay. And second thing is zero management. What is the meaning of zero management is take a same query, you updated the product. Okay. And you wanted to get a data before this update on some other day. Correct. What is your role play here? You need to put a, say this is a production system, for example. You need to put a mail to your administrator, Oracle administrator. Then he will look at your ticket and he will approve the ticket. And again, he will go back and he will fetch the logs. See, there is a dependency on this guy, right? So that is called as that is an example of zero management. Here, you no need to have a separate person to be secured. Okay, you can go back your data and you can get it. And also, this Oracle is again a server client policy. Okay, so there is a server available. Every time Oracle releases a new version, right? So when a new version is released by the Oracle with new feature, your server has to be enhanced, right? And also there are some security policies. So all of a sudden, a new virus came into the market, right? So you need to protect that. So Oracle will have a separate security policy updated. So that policy to be reflected in all client systems. Again, you need to have patches to be installed, right? Okay. So and say one person wanted to take a backup of your DB. What you will do, how backup is taking in the company, right? So you need to shut down your systems for some time, not much time. So then people will take a backup for disaster recovery or whatever it is, and again the system will be up. Here, Snowflake is taking care about all those stuff. You won't be spending the separate time for that. Being a developer or being a user, you will not be spending time on that. Snowflake is taking care about patches. Snowflake is taking care about versioning, so maintenance, so vacuuming, some other concepts. So you won't be paying for any management price. You will be paying for your storage and your processing only. Okay. To make it very simple, you are not actually paying the car rent, but you are driving, right? So you need to bear the fuel charge. How many people added in the back end is up to you. Okay, you need to pay the fuel charge. That's it. So no management. Say all of a sudden your car is damaged, you don't need to pay a management cost. So your car company will take care of it. Same, zero management, right? So you will see that actually. So in the management, no administrator required. So for a project, cost cutting, resource automation, right? So many people are actually not needed here. Okay, no separate administrator is required for the maintaining your Snowflake database. Okay, no security advisor is needed for that. But security is not violated, guys. Management is not violated, but that burden is not given to the vendors or users. Okay, all of your data. So it is making sure that none of your data is dropped or removed. I'll tell you a simple thing. This is my table, right? I believe some of you might be aware about it. If not, I'm just selecting the table. Sorry. I'm selecting a customer table from my Snowflake. Doesn't exist. Sales schema. I'm selecting a record from this table. Okay. This is my critical data. So say I'm dropping a table. Drop table. Say let us assume I'm working in a production system. What is the result if you do this? If you drop the table in Oracle or in SQL Server anywhere in production, you will be end up with pink slip also. Sometimes we don't know, but you no need to worry. So let me see here. I'm trying to select the table. No data, right? But you can undrop. You can undrop within 7 days. Undrop table. The table is restored. See, again the data is getting back. Also, I told you one example. At November 7th, one record is updated. So on December 10th, you can go back to the November 27th data and you can get back the data. That is called as a time travel. Okay, so that one feature called as a time travel. Using time travel, you can travel back and you can travel back and you can get the old data also. Not only the position of the data, you can get the data as well. That's why it is guaranteeing that all of your data is completely secured, and at the same time, so you can access your data after your lot of DML operations or after changes as well. Okay, same way all of your users as well. In Snowflake, we will be having a set of users, so they will all be they will all be secured as well. For example, 100 developers are there today, so tomorrow it would be 500 developers, and after some time there would be 0 developers, but still Snowflake is maintaining the data for all 500 developers like any other warehouse. Okay, and important thing is pay only for what you use. Okay, here you have a set of storage, right? And you will be paying for that storage only. Okay, and you are running the query for, see, now I ran the query for a minute only, correct? 47 minutes, 47 milliseconds I have ran the query. So I am chargeable for 47 milliseconds only. When my system is at idle, I will not be charged for anything, right? And also one more advantage is I'm running the query, right? This is the third time I'm running the query. Do you believe me? Here you can see the history. Same query, I'm running twice. But I will be charged for the, if you run a duplicate query, you will be charged for one time only. That is the one more thing. So that kind of things are there. So it is an example for pay only for what you use. Though you are running query multiple times, say if I run a select star on the 500 TB, I will be charged for only one time. Right. So that is the one more benefit. Live data sharing means you can share the data. This is the Snowflake. From here, you can share lively to the reporting systems like Tableau or all those guys. So these are the few features. So whatever I dropped and dropped, right, that is called as a fail safe. Fail safe, zero copy cloning, and time travel, zero management, SQL DB. So these are the few benefits. Any questions on these benefits? Right. So finally, this is a comparison between the Snowflake to other warehouses in the market. So you will have broader performance. It supports a JSON data and it is very scalable. So you can scale up and down. It's a multi-warehouse. Okay, and it's a multi-cluster warehouse. Okay. These are the few things I would like to share. Overall, I wanted to make you comfortable on what is warehouse and various kinds of warehouse, where we are building, what is Snowflake, why Snowflake is very good in the market. Right, this is a small introduction I wanted to give you about a Snowflake. Please feel free to express your doubts.
Yeah, I have a question.
Yes, please.
Actually, I joined little late. So, could you tell me like what all will be covered as part of this course?
Yeah, definitely. Snowflake curriculum. So I'll be covering all your warehousing concepts. Okay. So Snowflake and connecting to the Snowflake. So various kinds of connections to the Snowflake. We will be having web UI connection. So and also various places we can work. So we can work through the EC2 instance in the cloud, and we can work with the web UI using DB. DB is a place where we can run the queries, and web UI is there. Okay, we will be connecting, and also I'll be helping you on the understanding the AWS service. I'm an AWS guy. I'm helping you on understanding the AWS with Snowflake, and I'll also teach some basics on the Microsoft Azure with Snowflake also. Okay, so these are loading and unloading the data from Snowflake. Okay, so where and I'll be using the Snowflake, so we can work with the data pipelines and data sharing, managing your billing and all. So this is the billing details, understanding the securities in the Snowflake. So any performance tuning, some scenarios. So, and I'm going to give you one sample project on the transport system. Okay, we will be understanding the transport system along with the warehousing concepts. Okay, so along with this, you will be also seeing the basic understanding of the Python. So we will be working with Python in the Snowflake.
Okay, thank you.
Okay. So this duration overall, the course plan is like this. So I will be having one lab exercise parallelly along with me. So and at the end of the class, you will be having one transport project, that is your project you need to do, and I will be helping on that, and I'll be correlating that project to the existing warehouse. Okay. And some questions and answers. I have some set of questions and answers that will be useful for your certification. Okay. I cannot say I'll be providing good support for certification, but whatever the questions I have faced during my certification and based on other classes, I will be holding the things to you. So, and you will be also getting the basic knowledge on Python. I'll be showing some Python with SQL steps. This is a place where you will work. This is a program, simple Python program. It's a simple Python program along with the Snowflake. So overall, Snowflake, you will be working in so many places. In my class, I show you Snowflake work in web UI, and the Snowflake work in the some other system. This is called as like a Toad and SQL Server you are seeing, right? And Snowflake in the Python. So these are the few places I would like to help you, because different companies are preferring different web UIs or different environments. At least I'm not telling you that I'll make you proficient in every environment. My responsibility is to give a basic knowledge on this tool. So, and one or two exercises like in your college, right? Yeah, that's. Am I helping you, Suresh?
Yeah.
Oh. And any other questions from anybody? Yeah, that could be question, could be any question. So you have gone through a lot of research, right? So any question is not a bad question. So as I told you, prerequisites are, the first prerequisite is technical prerequisites are you will be getting technical help from me. So, and at least you need to brush your SQL skills and also cloud skills. Okay, you can go through the lot of videos available in the YouTube. Just go and get a basic knowledge, SQL one. And if you are already from ETL background, that is really helpful. And if you are already from data warehousing background, so it's a real fit for this. But you are not from the, you are as Sai, if you are from non-technical background, don't worry. Or if you are from any electronics background or any other non-IT background, non-computer science background also, don't worry. And the last is the only thing. So practice along with me. Definitely you will be getting the good knowledge. Yeah.